Hello guys. Okay, so this is the second part of the question. This is question 2 of those revision questions. We've got 11 in total of that set. We've just done this, and this. This is the other video. And now we're gonna have a look at this part. So a chi-square test for independence was performed on the collected data at the significance level 1%, right? The critical value for the test is 13.277. And then we've got a few questions. So this is the chi-squared test for independence, right? Okay, so as we have seen in class, this is a test to determine whether two variables are dependent or independent. So, for example, we can say, is gender dependent or independent of exercise habits? So are girls doing more sports than guys, or the other way around? You can always ask yourself questions about two variables and how they are dependent or independent. And here we're looking at this contingency table. So we've got two variables. So the first one is up here and the second one is up here. So the variables are given by the rows or the columns. So variable 1 would be the age range, or the age, whatever. And the variable 2 is the preferred device. So the question that we ask ourselves is, are variable 1 and variable 2 related? Are they dependent or not? In other words, can we say something about, I don't know, that 11 to 13 years old prefer laptops or mobile phones more than 17 to 18 years old? Something like that, So that is something we're gonna test. And how we do that, with the chi-square test for independence, the first thing we do, and that's also the question, state the null and alternative hypothesis. So what we do, guys, we have the null hypothesis and the alternative hypothesis. We write it down like this, and that is like making a statement. That's what we're going to test. And the first one would be to say that the two variables are independent. So that's always our null hypothesis. So here it would be age range and preferred device are independent. Okay, so that's important. That's the first one. And the alternative hypothesis is that the variables are dependent. So we would say age range and preferred device are dependent. Okay. So this is what we're gonna test, and we don't know this yet, so that's the big question. And we're gonna do this with the chi-squared tests, as we've seen in class. So remember, we had two methods. Methods 1 and method 2. Method 1 is to compare your chi-squared calculated with your chi-squared critical. And we're going to see which one is bigger. Or the other one is to say, let's have a look at this p-value that we can also get from the calculator. And we're going to compare it to the significance value. Significance value. And we're going to compare that one. I like this pen. This looks pretty nice. So this is what we're going to do. We've got two methods. And depending on this, depending who is bigger, we're going to either accept or reject the null hypothesis. Okay? So let's go step by step. So let me delete all this stuff. Yeah, so we have now stated what our null hypothesis is and our alternative hypothesis. So that was the first question. C, write down the number of degrees of freedom. So the degrees of freedom, this is also what you can get from your calculator. So again, remember how you get all that information from your calculator. I gave you this little piece of paper where everything was explained in steps, remember? So you basically have to go to matrix, and then you have to create your matrix. So you just plug in this thing, guys. So you don't add the total row and column. You just put this 3x3 matrix. These values, you put them in, you plug them in your calculator. Yep. And then you will go to, what is it? You have to define your matrix A, right? By pressing STO and then A and then enter. But you have to do control also, control STOA, right? All that's the steps. And then you go to statistics, and then statistic tests, and you go to chi-squared. So all that stuff was explained on that little piece of paper. And then you will be able to find the degrees of freedom. The degrees of freedom will be given, degrees of freedom, and that should be 4. Why is it 4? Because the degrees of freedom are given by the number of rows -1 times the columns -1, and you multiply those two. So how many rows do we have? We don't take into account this one, huh? So we've got 1, 2, 3. We've got 3 rows. So we've got 3 minus 1 times number of columns. We've got 1, 2, 3 columns. So 3 minus 1. So that is basically 2 times 2. So this is 4. So the degrees of freedom is 4. You don't have to do this calculation. You can just get it from your calculator, okay? So this will be given by 4. Okay, so that is the question C. Then D, write down the chi-squared test statistic. So chi-squared test statistic, when they say this is actually the chi-squared calc, as explained in the slides and in my summary sheets. So this thing, the chi-squared test statistic, is given in your calculator if you follow the steps that we've done in class. So in that same window as you found this thing, you will find the chi-squared test statistic. And the chi-squared calc test statistic is 23, let me double check, 23.3258. So that is also 23.3 if you want to round it. So that is the chi-squared test statistic, okay? And then they say write down the p-value. The p-value is also given in your calculator. So if you look and you follow the steps, the p-value will be given and it's 0.000109. So that's a very small number. Okay? And then the last question is state the conclusion for the test in context. Give a reason for your answer. Okay, so again, remember how we work out the chi-squared t statistic. So that's also given. Oops. Let me do that. Oh wait, I'm just. Is it this? I'm still getting used to my tablet, guys. Oh, here it is. Okay, so with this chi-squared test statistic for independence, test for independence, we have two options. We can either compare the chi-squared, let me see, chi-squared calc we compare the chi-squared calc to the chi-squared critical, or we compare the p-value as I explained, and we compare it to the significance level. So let's do this together. What is the chi-squared calc? The chi-squared calc is 23.3. What is the chi-squared critical? That one will be given. They say the critical value for the test. So the critical value, they mean this, the chi-squared critical is 13.277. Okay? So in this case, if we use this method, if the chi-squared calculated is bigger than the chi-squared critical, which is the case in this case, what happens? We reject the null hypothesis. Okay, we reject the null hypothesis. So if chi-squared calculated is bigger than the chi-squared critical, we reject the null hypothesis. So we reject the fact that our variables are independent, so we conclude that they are dependent. We basically conclude that the preferred device and the age are dependent. Okay? But we have another method. We can either do this, as we did, this is method 1. Method 2 is to compare the p-value to the significance level. So if the p-value, and now it's tricky, if the p-value is smaller than the significance value, then we reject H0. So here, pay attention. With the chi-squared method, you have to be bigger than the critical one to reject the null hypothesis. And here with the p-value, you have to be smaller than the significance level, and then you reject. So let's see if this is the case. So p-value, what was our p-value? Was 0.000109. And the significance value that is given, what was it again? They say a chi-squared test for independence was performed on the collected data at the 1% significance level. So this is 1%. So that's also 0.01. So does this hold, guys? Let's check. The p-value is this, right? 0.00109. The significance level is 0.01. Is this indeed the case? Is this one smaller than this one? Yes. So we are going to reject. And indeed, the conclusion should be the same in both ways. So if you have, it should be the same. So here we reject H0 and here we also reject H0. You can decide which one you use. Because in this case, both are given. We have the chi-squared critical value and we have the p-value. Sometimes not all the information is given, so then you have to be smart which one to use. But now you could just pick any one of the two. And so that is the answer. We can reject. So the conclusion is reject H0. So the preferred device and age range are, and what is it? Let's have a look again. If we reject H0, how did we define H0? So H0 is age range are independent. If we reject this one, then we go for H1, and H1 says that they are dependent. You see? So our conclusion is that the variables are dependent. So preferred device and age range are dependent. This is what you're supposed to write, guys, with your chi-squared conclusion. State the conclusion for the test in context, give a reason for your answer. So giving the reason is this. You could either say that the chi-squared calculated is bigger than the chi-squared critical, and that's why you reject H0, or you can say that the p-value, which is this, is smaller than the significance level. Okay, so that is question 2. That is the chi-squared question. See ya!